हम लोग हाई स्ट्रेंथ डिफॉर्म्ड स्टील दैट इज यूज्ड इन कंक्रीट स्ट्रक्चर के बारे में स्टडी कर रहे हैं। IS 1786 2008 में डिफरेंट ग्रेड की कितने ग्रेड की रिवार होती हैं, जैसे Fe415, Fe415D, Fe500, Fe550D एक्सेट्रा। उनके मैन्युफैक्चरिंग कैसे होती है, किल्ड स्टील क्या होती है, सेमी किल्ड स्टील क्या होती है, उसमें मैक्सिमम मात्रा में कार्बन, सल्फर, फास्फोरस कितना होना चाहिए, यदि इनकी क्वांटिटी ज़्यादा या कम है तो हाउ दे इन्फ्लुएंस द प्रॉपर्टीज ऑफ rebar. All this we had studied in our previous video. Now in this video we will be studying about the physical properties of the rebar steel, जिसमें elongation, yield stress, ultimate stress, ये सब के बारे में हम लोग स्टडी करेंगे। जैसा कि हम लोगों को पता है कि डिजाइन इंजीनियर्स यूज द yield stress property of the rebar for calculating the quantities in their design। कितनी मात्रा में स्टील का किसी भी स्ट्रक्चर में यूज होगा, उसका यील्ड स्ट्रेस के ऊपर में ही उसकी कैलकुलेशन करते हैं। जैसा कि इसके फैक्टर ऑफ सेफ्टी भी 1.15 के बराबर लेते हैं। अब इसमें चूंकि स्टील लो कार्बन स्टील है, जो रिबार है लो कार्बन स्टील है, इस पे डिफाइंड यील्ड पॉइंट नहीं होता है, जबकि इन माइल्ड स्टील केस में अपर यील्ड पॉइंट, लोअर यील्ड पॉइंट सभी डिफाइन होता है। सो स्ट्रेस स्ट्रेन कर्व के बारे से हम लोग स्टडी करेंगे कि हाउ द स्ट्रेस स्ट्रेन कर्व इज फॉर द माइल्ड स्टील एंड हाउ इट इज फॉर द लो कार्बन स्टील एंड हाउ टू फाइंड आउट द प्रूफ स्ट्रेस। सो दिस इज द स्ट्रेस स्ट्रेन curve for the mild steel. In this mild steel exhibit all the properties like what is upper yield, what is lower yield, what is ultimate stress point. All these are well defined in the case of mild steel, but in the case of aluminum, copper, low carbon steel, it is not defined. So for that we need yield offset, where the rebar behave up to yield stress, and after that it goes into the plastic deformation. So all this we will be studying in this video. So for the mild steel, from O point to A point, this is in proportional limit from point O to A, where the stress is proportional to strain. इसे मॉडुलस ऑफ इलास्टिसिटी भी कहते हैं। स्ट्रेस बाई स्ट्रेन इज ए ई, मॉडुलस ऑफ इलास्टिसिटी ई इक्वल टू stress over strain in OA region. Means once load is removed from the specimen, it will regain to its position. But O and AB up to B, where even though elongation is more, but once load is removed, specimen will regain its original shape. But at point C, which is upper yield point, after this, once we apply the load up to upper yield point, after the upper yield point, the material will not regain its shape. It will be in the permanent deformation. So in this region, upper yield to lower yield, it will be in the permanent deformation. After that, strain hardening will happen. The molecular structure of the steel will rearrange themselves, and against the load they will act. So it will take more load to deform. So, but the elongation will be more. So in the region of strain hardening, their load application will be more, and then it will reach to the ultimate stress point. After that, the loading will be reduced, and ultimately it will break and fracture. So all this is a stress strain curve for the mild steel. Now for the low carbon steel, this particular yield point will not be defined. There will be drop in the about 0.5% drop in the load will be there, but sometimes it is not visible. So graph will be the yield point will not be defined, and graph will proceed like this, and will ultimately it will fracture. So how to find the yield stress point, which is required for the design purpose by the engineers. Design engineers are interested to know what is the yield stress point. So this is obtained by 0.2% proof proof stress. And how to find this proof stress? Now, if we in this graph, if we see this region from upper yield point to lower yield point are beginning of strain hardening. The quantity is 0.002 times of the elongation. Whatever material is there when it is stressed, about 0.002 times of its if we put its length, if we put in the tensile machine, if this is the specimen and if this is the 500 gauge length, when we apply the tensile force up to 0.0022 times, means 500 into 0.002, say about 1 mm. One in this region will be about 1 mm straight. Then it will go in strain hardening position. So this is the 0.2% proof corresponding to this load. The load is known as a proof stress load. Now in this graph we can understand very well. This is graph for low carbon steel, in which yield point is not defined, but we need the yield point where the material has yielded, means yield point. After that it will go to the plastic region. Up to yield point it will come, stress will be almost proportional to strain. So we are interested to find out what is yield point of this. For that if we take this expression and mark the gauge length of gauge length as it is given in the code 5.6.5 root a, and this is the gauge length for 20 mm dia steel. Area of cross section is 314.3 mm square, and gauge length will be 100.16. If this expression we take into the UTM, and then for this to stretch this particular to 1 mm, this is a gauge length is 100, so 0.00002 times of this gauge length 100, about 0.2 mm. After taking the reading, we draw parallel to this line, strain curve line, and wherever it intersects with this line, this curve line, the corresponding load, we take the corresponding load, divide by its area of cross section, we get the proof stress. So after getting the proof stress, that is used in the design. Wherever the yield is not well defined, there we use this 0.2% proof stress. Proof stress is nothing but the permanent deformation, where permanent deformation takes place in the steel while taking the load. That is the yield stress, and that yield stress is being utilized for the calculation purpose in the design. So with this we have completed the proof stress of steel, and after that we will be taking up the physical properties. Thank you.